Hey everyone, welcome to another video in our Year 8 Linear Relationships course. Now, in the previous few videos, I've talked a lot about these different aspects of my relationships. I talked about the gradient, we talked about finding certain points if given a linear relationship, so checking points on a line. Now, I'm just going to take a little bit of time to talk about the idea of finding a pattern. So, when we're given a few points, trying to find an unknown pattern from these. And some of you may be quite inclined for these. So, you may have not too much trouble just finding a pattern between each of the numbers straight away. But for some of you that may not be, I'm going to go through this really slowly so you can hopefully see the line of thinking, how we could kind of go about finding these patterns, as well as some little hints and tricks, and just kind of see the general power in something like this. So I have here a table. So these linear relationships in general are all about relating two variables. How do these variables change with one another? How does x change with y? And you may remember a lot of these came in the form of y equals mx plus b. And we thought of this as we can make y out of some input into x, as well as these other two elements here too. One being the gradient, one being the intercept. And in doing this, I want to try to relate these variables from my x's to my y. And in doing so, I'm going to get some numbers that I can substitute into here. Now, I won't always get these numbers, but more often than not, there will be some gradient and intercept linking these two together. Now, first of all, I just want to see the pattern in terms of how are each of these changing. What am I doing to x to get y? Now, when doing this, there's a few things that we may notice. So we may go, okay, well, each of my x variables are all, let me rub this out, these are all going up by one, right? My input that I'm putting in, it's going up by one. So x changes each time we are adding one. And my y is changing by going up by 2. So here we're adding 2, we're adding 2, we're adding 2, we're adding 2. Now, what we have here is our y is changing by 2 for each change of 1 in x. Now, that may sound familiar to some of you, hopefully, if you've watched the last videos. This is the definition of the gradient. So the gradient tells us a relationship between y and x, where if x goes by 1, what does y go up each time? And that, in essence, gives us what our gradient is. So if I wanted to come up with a pattern here, well, my y would equal 2x plus some other element, because my gradient tells us the change in y for each change in x. So all I know here, and this jump between every single time, that's going to be my gradient. We'll see this in the later example too. But once we get here, some of you may already be able to see this from just looking at these, but something I'm doing to this x is I'm multiplying it by 2. So I'm multiplying each of these numbers on the top by 2, and I'm doing something else to them to get all of the ones on the bottom. And to find this, if you don't see it right off the bat, we can check by saying that all of these values, as we talked about in the last video, all of these numbers, for example, 2 and 5, these pairs of numbers, 2 and 5, 3 and 7, 4 and 9, 5 and 11, 6 and 13, they all satisfy this equation. So they make the left-hand side equal to the right-hand side. So let's check some values. So let's take 2 and 5, for example. Well, 5 as my y equals 2 times x, which is 2, plus some constant b or c. Now, 2 times 2, what does that give me? Well, that gives me 4 plus b equals 5. So what number adds with 4 to give me 5? Well, that is going to be 1. So b is going to equal 1. And you'll see that no matter which value we check this for, it will always work out in the same way. Because these are linear. They don't change. We kind of get the whole, we get this thing being true for all of the numbers. So for example, if we tried, let's go with the next one, 7 from the y equals 2 my gradient times 3 plus b. Well, 2 times 3 gives me 6. And we want a number that adds to 6 to give me 7. And that is the number 1. So b, once again, equals 1. Now, for you guys to do at home if you'd like, you can have a go at trying this for all of the other numbers. And you should see we're going to get the same value of b for these particular relationships between x and y. So our equation then is y equals the rule that links these two together. Let's do this in a different color. Y equals 2x plus 1. That is the rule that links x to 1. And what this allows us to do is that we can substitute in any values of x here and see what y is going to be. But now that we have this rule, we can use that. And we'll see how that works for the next question. Now, I said today that these linear relationships are all about finding patterns about how x and y change together, how two variables, how two bits of information change with one another. So here I have this pattern here. So I'm letting x be the number of squares and I'm letting y be the number of matchsticks. So for this question, I want to find essentially the rule that relates the number of squares with the number of matchsticks. So I'm going to draw up a table of values to put in all of the necessary information. So let's just count how many squares I have each time. I have 1, 2, 3, 4 squares. So my squares are always increasing by 1. So I have 1, 2, 3, and 4. And let's count now the number of matchsticks it took to make each of these squares. Now here I can count 1, 2, 3, 4. And here on this next one, I have 1, 2, 3, 4, 5, 6, 7. For the next one, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And by now, some of you may be seeing a pattern here, but it's all right. Let's just count the last one manually just to figure out. But we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Now, do you guys see a pattern for how my number of matchsticks change? Well, going between each of these, I'm always adding 3 as I go along down the line. Now, this means I have 4 matchsticks for 1 square, 7 matchsticks for 2, 10 for 3, and 13 for 4. Now, once again, I want to find a pattern, and I've already done one of the harder bits first. I have figured out that because my number of squares is x, my number of matchsticks is y, we're going to get some form, some linear relationship in the form y equals something in front of x plus another something. But one of those somethings, one of those missing pieces of the puzzle, we've already actually found, because in doing this counting and going, okay, plus 3, plus 3, plus 3, I have seen how much y changes for each change in x. I've found what my gradient is, what my unknown number here is. That's going to be, I'll do it in a different color, 3. Because my gradient, my coefficient of x, the number before x, you may remember from our last videos, that tells us how much y changes, how many steps y takes up for each horizontal to the right step in x. So I found my gradient, right? Now I just have to I know that x is being multiplied by 3, and I just need to find what's being added or subtracted to get to my final values here. Now, once again, some of you can probably pick this up already, but because once we get this first bit, it opens the question up completely. But let's just do our longer checking method to see what is happening here. So let's try this I did the first two in the previous example. So let's try this pair of values, 3 and 10. So my y is 10 here. So when I multiply 3 by my value of x, which is 3, and I add some number to it, here I have 3 times 3 gives me 9, and something is being added to 9 to give me 10. In the same way that something's being added to 3 times this value, for example, to give me 13, or this value to give me 7. It's constant all the way through these relationships. That's what linear relationships are all about. Now, from here, we can quite easily see, okay, when I add 1 to 9, I get 10. So this mystery number must be 1. So my rule relating my number of matchsticks to the number of squares I have is going to be y equals 3x plus 1. Now that we have a rule that goes all the way through, we can answer all sorts of questions. I can say, for example, let's call this the part B of the question. So we can say how many matchsticks are required to make 10 squares. Well, now that we've seen this pattern and we've found an equation or a rule relating these two, which was that y equals 3x plus 1, I can find all sorts of solutions to this. So I can say, okay, how many matchsticks are required to make 10 squares? Well, I have one of my variables in the question, 10 squares. And now my squares go in place of my x. So my y equals to 3x plus, 3, and what's my x? Well, I get 3 times 10 plus 1. So my number of matchsticks is going to be 30 plus 1, which gives me 31 as an answer. I could have found how many squares I can make from 100 matchsticks, or how many matchsticks I'd need to make, for example, 100 squares, or 1,000 squares, or any number. Because as I keep going, all of my squares that I make follow this rule. And you can hopefully even see it here in the image, right? I have an extra 3 being added here. An extra 3 matches. 1, 2, 3. I have an extra 3 being added. 1, 2, 3. Extra 3 being added. 1, 2, 3. I'm always increasing by 3. But now that we have a rule, we can solve a lot of different questions. I could also ask you, for example, let's go with, let's say, how many squares can I make with 37 matches? Well, that's not a problem to us because we have a rule that relates matches or matchsticks to squares. And that's this one here that we've already figured out. The hardest thing, guys, is figuring this out. But once we have it, it blows the whole question open. Now, here we are looking at 37 matches. So this number 37, I'm substituting that into my y because my x represents my squares. So if I do that, I now have 37 equals 3x plus 1. And I have an equation that I can solve. Well, I can now subtract 1 from each side to find what 3x was before I added 1. So that gives me 3x equals 36. And now I can just divide both sides by 3. This is just simple equation solving, which we've been doing for a while now. It's just a 2-step equation. And my value for x is going to be 36 divided by 3, which is 12. So once I have the rule, once I look at the pattern and establish my rule, y equals 3x plus 1, I can answer a bunch more questions from now on. And these don't change because they're linear. So we have a pattern that goes all the way through. You can even see from the shape pictures I had here, we're always adding 3. So the rule is consistent. But that is how we can work through these types of questions that require us to find a rule. Now that brings an end to our linear relationships topic for year 8. Thank you so much for watching, and I will see you in the next series.